Hello, hello everyone. This is Vairaj sir from SND College of Engineering and Research Center, Baroda. So today we are going to learn the deadlock topic from operating system subject. Okay. So in today's topic, we are going to learn the various concepts regarding a deadlock. So first of all, what is deadlock? So deadlock is a situations where all the processes are stuck at one position and no one process execution going further. Such a situation is called as deadlock. Means every process in the uh, system, not every process, or some of the process from the system are waiting for each other. Such a situation is called as deadlock. Suppose there are three processes, process 1, process 2, process 3, and or process 5, process 6, and some of them, we can say process 1, 2, 3, they are waiting for each other and their execution is stuck. No one process execution going further. Such a situation is called as deadlock. Means all processes are stuck at one process at one level. The processes are not waiting for each other directly, but also they are waiting for the resources which is held by the another process. Suppose we can say that the process one hold the resource three, which want to the process two. Process two held another resource which want process 3, and process 3 want a resource which is held by the process 1. In these situations, all processes are in circular manner. They are waiting for in a circular manner. Such a situation is called as deadlock. So in this session, we are going to see these three topics. First of all, deadlock characterization, deadlock, how to handling deadlock methods, then deadlock prevention, deadlock avoidance, deadlock detection, how to detect the deadlock, and suppose deadlock is happen, then how to recover from that deadlock. So these are the some characteristics we required, or we can say some four conditions required for the deadlock. First is the mutual exclusion. Mutual exclusion in the sense the two processes have want the same resource. Means the two processes have mutually want one resource. Suppose P1 want R1 resource, P2 also want R1 resource. Both processes are in mutually. So such a situation, we can say, for lead to the deadlock. Second, hold and wait. Some of the process are holding some resources and want the another resource, or they are waiting for the another resource. This is another uh, step, we can say. No preemption. No preemption in the sense that suppose I hold some resource and somebody want that process, but I will not release that resource. Means that process hold some resource and which she don't want, or it does not want to release that resource. Somebody want that resource, rather than uh, it will not going to be release that resource. That is no preemption. And circular wait, as we see that the processes are waiting in a circular manner, is called as circular wait. Okay, the four conditions are there. Mutual exclusion, both want same resource. Hold and wait means I am holding one resource and waiting for another resource. No preemption in the sense I hold some resource, I will not release that resource. And circular wait in the sense all processes are waiting in circular manner. These are the necessary conditions for the deadlock. The next is resource allocation graph. Some of the graphs we can say, or some attributes are there. So processes are seen in circular format. Resources are shown by the square, and the instances are shown by the very small square inside the resource. Okay. Request is, we can say, suppose process want a resource, then request is from process to that resource. Okay. Holding age is also there. So holding weight is from resource to that process is called holding edge. Here is the example of resource allocation graph with a deadlock. So see, we can see that P1 process want R1 resource. With that R1 resource held by the P2. P2 process want R3 resource which is held by the P3 process. And P3 process want R2 resource which is held by the P1 and P2 both. So in such a situation, suppose we remove that resources, we can see that P1 is waiting for P2, P2 is waiting for P3, P3 is waiting for P1 also and P2 also. There is a circular wait. So this is called as deadlock. Okay. See, processes are shown in the server, resources are shown in the square box, and instances are shown in that resource by the dark point, we can say. So R1 has one instance, R3 has a one instance, R3 R2 is there, R2 has a two instance, and R4 has a three instance. Okay, and three processes are there: P1, P2, P3. Next, basic facts. As we see, graph containing cycle, that is suppose here is a graph does not containing cycle, no deadlock is there, and graph containing cycle means there is a deadlock. How to handle the deadlock? So for handling a deadlock, two methods are there: deadlock prevention and deadlock avoidance. In the deadlock prevention, the necessary condition we have seen, that four conditions, we just have to eliminate that condition. For deadlock prevention, how we can prevent from the deadlock? So deadlock prevention, in the sense, suppose we have to eliminate hold and wait, we have to eliminate mutual exclusion, we have to eliminate uh, what that is no preemption, and we have to eliminate a circular wait. So these conditions are, suppose we avoid that four conditions or eliminate that four condition, deadlock prevention. Okay. Deadlock avoidance. The deadlock avoidance, in the sense, we have to avoid the deadlock. So how we can avoid the deadlock? Suppose we want all the execution of that all processes. How many processes are there? How many resources are in the system? How many resources, how many instances are there? So every process, we have to know the information about all process, which process want which process at what time. Suppose we have all that information, we can avoid it. That is deadlock avoidance. Okay. Two methods we have seen in this slide: deadlock prevention. Deadlock prevention, the necessary conditions, we have to eliminate that. What are the necessary conditions for deadlock? Mutual exclusion, hold and wait, no preemption, and circular wait. We have to eliminate that condition, deadlock prevention. Deadlock avoidance, we should have all information about all process, all resources, which process want which process at what time, we can avoid a deadlock. Next, this is deadlock prevention. Has we seen deadlock? Eliminate mutual exclusion, eliminate hold and wait, eliminate mutual exclusion, and eliminate circular wait. Deadlock avoidance. So maximum, we have all the information about resources, as well as priorities of that resources, maximum number of resources, all the information. Suppose we can avoid the deadlock. This is the next slide, where we can say that system is safe, system is unsafe. So very basic is that, suppose your system are having deadlock, which is your system is in unsafe state. And if your deadlock does not having deadlock, your system is in safe state. Deadlock detection. So for deadlock detection, we have two algorithms in our syllabus. First of all is the resource allocation graph is there. So just we have seen in our third slide, resource allocation graph is that which process want which resource, and which resource is held by the another process. Okay. So very basic is there. Suppose some process requested that resource, so we have to draw the line from process to that resource. And when we that so we say that keep R2 R2 resource is held by the P2 process, then we have to draw the line from that resource to that process. Okay, so that is deadlock detection. Suppose in a resource allocation graph, the circular weight we found, that is deadlock detector. And another for avoiding we use bankers algorithm is that. Then last topic from this session is deadlock recovery. See, this is resource allocation graph. P1 process, P1 process want R1, that R1 held by the P2 process. P2 process want R3, that held by P5. P2 process want R4, that is held by P3. P3 requested for the R5, which is held by the P4, and P4 held by the R2, which is held by the P1. Suppose we eliminate all the resources from the slide or diagram. So we can see that, see, directly we connect that edges to that process to process directly. P1 is waiting for P2. How? See, P1 is waiting for R1, R1 is waiting for P2. So we directly draw that edge. P1 is waiting for P2, P2 is waiting for P5, but P5 is not waiting for another one. P2 is waiting for P3, P3 is waiting for P4, and P4 is waiting for P1. So in this situation, we can say that two deadlocks can be occur there between P1, P2, P4, and P1. Between P1, P2, P3, P4, and P1. Between P2, P3, P4, and P2. So many deadlocks occur in this time. Okay, means system is in unsafe state. So deadlock termination. So, or we can say that deadlock recovery. So basic concept is deadlock recovery. So how we can recover from the deadlock? So two basic methods are there. First of all, process termination. So process terminations, in the process termination, we have two choices. We can eliminate all the processes which are in the deadlock, but it is a high cost. Suppose P1 process, P2 process, P3 process, P1 process completed up to 90%, P2 process up to 60%, P3 process completed up to 30%. So we kill all the processes which is in deadlock. So we have to start that process from their starting point, from zeroth level, from 0 point. So 1%, 2% again is there. So we cannot afford that cost. Means from starting we have to start, no? So the another process in process termination. So whatever the processes in deadlock, kill one by one until deadlock is not. Means P1 process, P2, and P3 is there. In first situation, we say we kill all the processes, deadlock is eliminated. But in the another situation, we kill one by one. Suppose P1, P2, P3 is there, we will kill P1, deadlock terminate. So we did not need to kill another two processes. So it will minimize our cost. Okay. So two methods are there: about all processes, about one process one by one, and until deadlock is not met. Then another point is that, so we have to resource preemption. Okay, first is process termination, another is resource preemption. Okay, so in resource preemption we have to preempt the resource. Means how? Select as a victim. Select as a victim means selecting a process for the rollback, that is select as victim. Rollback means take one step backward until deadlock you will not release. One by one, roll back, roll back, roll back, roll back. Deadlock is break. Okay, stop over there. Again, start this. Again, start this situation. And start mission means we are selecting same process as select as victim, select as victim, select again and again. The same processes are selecting or select as a victim, and deadlock is happening. Such a situation is called as starvation. Okay, so that is deadlock recovery. As an exam point of view, deadlock recovery is very important. What is deadlock is also important. So just take a look of it and come to me if you have any problem. Okay, thank you so much. Bye bye. Take care.